okay, and 35, 100 feet, 0.35 feet. This is the answer. See, the answer is very simple, but just we need to understand what the question is telling about. If you go to the question again, you will find it very easy. If the elevation of the level instrument mean HI already, HI already here, HI already give it to you, and HI is already 100, 106.57 from inch. And the reading here in the scale, in the road scale, is telling you 6 feet and 0.22 from feet. So the elevation of point 1, B1, is equal 100, 106.57 from feet minus 6 feet, 0.22 feet. It's equal 100, and the answer is all correct here. I will answer number 4. Actually, I've just read number 5 today from a few minutes back when I am trying to prepare my class. So number 4, I will say is very easy as well. It's matter of how to convert the from feet to inches, and because here 6 feet, 6.5 inch, and we have 50, and this is 50 feet now, 50 feet now. So you have to convert, and minus, one of this answer, A or B, because what would be the station of the new point? Of the new point actually is plus, it's not minus, it's not A or B. Anyway, this is what I told you. Today we are going to discuss about slope and deflection first. Slope and deflection happen in a structure system, and I will give detailed about it. If you are open the slides, which I already sent it in our WhatsApp group, I send already a very important slides, slope and deflection. This is a one, and all these slides already with all in your hand. You can print it, and it's very important. Actually, it's very important. So if you start reading, and it starts see whatever I need here to do. Always deflection, any structure system or structure element deflected. Start from cantilever, beams, frame, trusses. Type. How can we measure the deflection, and what is the slope, and for any beam, any concentrated beam. If you have if you have particular cantilever, and this cantilever fixed end by this way. You have cantilever, and this cantilever fixed end, and this is concentrated load. Under this concentrated load, uses fixed end, this is a deflection line. We call it deflection line, elastic line. This is a deflection. This is what is the slope then? The slope here is a theta. Okay. How we calculate? There is equation for all this type of system. يعني simply supported beam, a cantilever, simply supported beam with concentrated load in the middle. مثلا, for example, if you have simply supported beam and this simply supported have concentrated load in the middle, so the deflection is coming underneath the load, and this is a deflection line, and this is deflection value, and is a deflection. It will keep linearly in this a fixed in concentrated load, and this is theta. Now, if you have uniform load on a beam, this is uniform load, How is this beam deflected? It will be take a parabola curve deflected deflection line. We call it a elastic line. This is a deflection amount, and this is theta. Theta always is tangent to this parabola curve. This is a slope. So as much as tangent the slope here, this is a slope at this point. At this point. At this point here, this is the slope. But now the slope is this point. The slope in the mid of the span always parallel to the beam itself. That's meaning the slope is equal 0 here. The mid span slope is equal 0. And this is one question from our exams. Tab, okay, very good. What else we have to know about cantilever and beams? Let us see our slides. Let's see our slides. What will tell us about what? See. Frames itself deflected. Deflected if you have a concentrated load in the joint, always frame deflected in the joint and supports. Means what? See, this is already deflected. The joint already takes this deflection line, and even the roller support, it will be deflected. Deflected. This in frames. And it coming in, as I told you, in the beam, in the beams, yes, here in the beams, this is a beam deflection slope A tick, and this is deflection, and this deflection is actually is linear. It's not parabola curve. If you have uniform load, it will be parabola curve. This is a very important slides which don't memorize them. You don't need to memorize them, but you have to understand the concept here. You understand the concept. Let us see the first case. The first case is cantilever type, cantilever beam, cantilever type, subjected to moment in the free end, moment in the free end. When you have moment in the free end, that's meaning maximum moment here, the reaction of this action moment is the same M. Your maximum bending moment is M, correct? The slope is what? As I told you, this type of cantilever type, it will be slow deflected like that. I will show it to you. When you have cantilever subjected to moment, by this moment, and we have reaction here is moment. This is a maximum moment, and still it will be deflected the same. It will be deflected the same. And this is a slope. This is a slope, and this is a deflection. If you go to our slides, you will find out slope function of what? Function from M. As much as M getting more, getting increase, and the length of the cantilever getting increased, the slope it will be increased. Type to resist and to make it to resist and reduce the slope, you are going to increase EI. What the meaning EI? E اللي هي modulus of elasticity and area of inertia. I اللي هي moment of inertia. Moment of inertia. طيب. البلاستيك have modulus of elasticity different than copper, different than aluminum, different than wood, different than steel. Okay, different than concrete. يبقى now to reduce the slope, you use rigid material. Rigidity, we call it rigidity. EI, we call it rigidity. So as much as you increase the moment of inertia, slope decrease. يبقى function of C, let us see function of M and L, because this cantilever subjected to moment. But what if subjected to load? W, we call it W. This is a load. W is equal to B. Weight, whatever load. If you see maximum bending moment is equal WLS, because moment here is what? L multiply W. This is the maximum moment. And as well as theta is equal what? Theta equal M moment. What is the maximum moment? Coming from W multiply L. WL square. يبقى then WL square divided 2EI. Divided 2EI. WL square divided 2EI. This is the theta اللي هي slope. Deflection function in theta and the span of the system. See all of them, span of the system. Span. Coming here values. Did I need to memorize? No. Did I need to memorize? No. Coming in cantilever subjected to uniform load, and cantilever subjected to linear load, beam subjected to concentrated load, and the beam subjected to uniform load. Okay, very good. If you see now all this table, just try to understand the concept here. The slope, about the slope and deflection. As much as the span increase, as much as the load increase, as much as the slope and deflection increase. To resist and to reduce this deflection and the slope, use high rigidity material. High rigidity material means E modulus of elasticity should be high and the moment of inertia should be high. What's the moment of inertia affecting the slope and deflection? I will just give you a very, very small, very beautiful hint about the moment of inertia. And you're memorizing everything. If you have beam, this beam has this section. This will be, and this is H. This section of the beam B, and here is H. And say different section have B, this H, and B, and here H. The moment of inertia for case number 1, the moment of inertia of case number 2, the moment of inertia I equal, case number 2 equal, B H cube divided 12. L1 equal, case number 1, the moment of inertia equal LB H cube divided 12. Which one have more moment of inertia? Case number 1 is more inertia. Number 1 is more than inertia 2. That's why we can design stiffeners, beams with small b, and too much increase the height of the beam, the depth of the beam. It will give you more rigidity. Okay, this is very simple, and this is a principle of the design. Whatever steel structure and concrete structure. I believe it's obvious now about what the meaning in rigidity, I will show you one question from previous exams is related to this point. Okay, let us see. See guys, this question number 11. The beam section shown are fabricated from 1/2 inch multiply 6-inch steel plates. Okay, we can fabricate it any section years by BEB say building design. We have BEB buildings. and hot rolled section is standard sections. But we can fabricate it, refer to your design. And sometimes for big warehouses, more economically, you have BEB section. BEB section, it's more economically. Why? Because you are using as a material in a good effectively. But the hot rolled, the standard hot rolled, small project, a small size of project. It's not, is a house, small warehouse. But when you have a big warehouse, it's better to have BEB, pre-engineered section. We call it pre-engineered section. This is pre-engineered section, fabricated from a plate. This plate size is 6-inch plate, and thickness is ½ inch. Which of the following cross section will provide the greatest flexure? Flexure as well, we call it rigidity, flexure rigidity about x axis. Which is the answer? Which is the answer? The answer, the moment of inertia for section D getting higher than any any other option. يعني D, the moment of inertia for D is more than A, than B, than C. Clear, guys? I wish you can write it down or take screenshot for this question, because this is very important to keep it in your system, and this is very important questions. Okay, another one.
So 1 second, we are taking the screenshot.
Guys, please. Okay. This one. This one. I just showed you right now, giving the two beams analysis as shown below. Find theta B at the first beam. This cantilever beam fixed end at A, and the first beam subjected to concentrated load in the free end, and second beam subjected to moment. Okay. If you remember the values, what I give it to you now from a few minutes back, it's giving you here the slope equal ML divided in EI, remember? And the deflection is equal ML square divided to EI. Coming here for case beam number 1, a deflection is giving you BL, W L cube divided 3EI. Very good. So now, EI constant. Let us see the option. Is giving me find the 7 mistakes between A and B. Select one. A will be with C with D. For sure 100%, the slope should be function of B will L divided something EI. طب let us see option number 1. Option number 1, there is M down, 16 MEI, wrong. Option number C, L square, and there is no M because it's subject to concentrated load. BL. Giving me moment, yes. What's the value of the moment? BL. Okay, divided 2EI. Okay, this is a BL square. Very good. Tab C number C, ML square divided 2EI. يبقى C is wrong as well. Tab C number D, 3ML divided 18B EI. Logically كده, use your logic, the answer is B. The answer is B. And all our exam, guys, use your engineering sense and logic. Almost you can solve a lot of questions, if even with a minimum effort, studying effort. Okay?
So what is the point of giving the second beam?
Sorry?
What is the point of giving second beam in this question?
First beam, concentrated load.
Yes.
Concentrated load, اللي هي B. Second beam is subjected to moment. Is asking you what is the slope for first beam اللي هي is
Yeah.
subjected to concentrated load.
Yeah,
Concentrated.
the question is for the first beam. So why the second beam is provided?
Provided like to check. You can memorizing here. I will show you why. Did you memorizing here? Did you memorize all of this one? You can memorizing? Tell me. You can memorizing all these values? He will give you a hint. He will give you a hint.
Okay.
How to you choose the correct answer without even you are even far away from studying. You cannot memorizing all this one. I told you don't memorize. We have already in the slides here the both cases have concentrated load 1 and 2, 1 and 2, and see the slope at the concentrated load here is equal WL. W يعني B L square. W here الويت اللي هو اللود. W B L square divided 2 EI. But if you go for our slides, if you go to our question, giving you as hint, see function of what? The slope function from ML and EI. That's it. So all the option you have what? A function of what? Function of 16M down. يا راجل بقى this 16M is correct answer? Down? No, is wrong. You have to consider both cases. طب B, forget about the B now. Forget about the B. Go for C. ML square. As a Kansas concentrated load, why you will put the M? Why you put the M as a delta B here? Delta B equal M L square to EI. He gave it to me here. يبقى this is wrong. يبقى ال A والC is wrong. طب ال D 3ML as well is wrong because ال B down. Why shall I will put B down? That's why he give you this case as hint to measure it, to make it as a baseline, to measure whatever case A to case B. Did you got it or not?
Sir. Clear, sir. Thank you.
Let us go for our second point from our class. That's meaning we have now slope and deflection. This is a way. Is this slides you have it in your in your WhatsApp now? I believe this file you have to print it down because there is a lot of questions here. You have to solve them. And now we discuss about deflection for cantilever, beams, frames. What if for our here a lot of cases here, a lot of cases to give it to you, but not important to memorizing the values, but as much as you understand the concept here. You understand the concept here, how the beam rotated and deflected, how the beam rotated and deflected, how the support, the members on the structure system in the support rotated and deflected is very important. We have what is EI? EI means E modulus of elasticity and I means inertia. Always giving to be constant or given to your exam. Coming to our trusses here. This truss. Okay, the truss, guys, when you deflected, I will just give you a hint for trusses. Assume you have a truss. And this truss by this beautiful system, you have joint, you have member, and you have member, and you have joint, and you have member, you have joint, member, joint member, and member. And this is roller support. And here is hinged support. You have load applied in this system here, in this joint A, and this is B, whatever the dimension or whatever the system dimension system. This B apply a concentrated load on the joint A. In your opinion, this A, it will go in this direction or not? Could be or not?
Yes.
Could be. That's meaning we call it what? We call it a horizontal deflection. This is horizontal deflection. Yes or not? Yes or not? Horizontal. Agreed, guys, or not?
Yes.
Yes,
Yes.
or no, whatever. This could be deflected horizontally or not. Why? Guys, please tell me. Send SMS, yes or no? Yes or no? Deflected horizontally or not? All of you guys.
Yes, it is. It is deflecting horizontally.
Deflected in H type. Deflected in vertical. Deflected in vertical is not in the same time. It's not in the same time because cannot be in horizontal and vertical in the same time. Can be deflected in vertical like that. Can be or not?
Yes.
In the same time? In the same time, this joint, it will deflect it diagonally, inclined, like that. This joint, due to this load, it will be diagonal like that. So that's meaning this joint, it will this member, it will be deflected this, and this member, it will be deflected in this. And this sigma between, you can calculate horizontally only, and you can calculate vertically only. In the end, you take the summation of them and take the resultant of it. Take the resultant of that sheet. That means what? This free end joint, you can rotate it, and can rotate it in both directions. That's meaning can deflect it in two directions, the horizontal and the vertical. يبقى this case number 8. What about joint B? Joint B, this have a load B2. This is B1 and the B2. This load applied on the joint B. In your opinion, this joint free in H direction or free in vertical direction? Vertical direction. If this load here applied horizontally, means what? Vertically cannot. Vertically because it's tight here. It's tight here. It's tight here. That means what? Vertically cannot deflect it, but can be deflected horizontally. Horizontally, yes. Can be horizontally. If deflected horizontally, it will go in this direction. If this deflected, that's meaning this one as well deflected. That's meaning this is a system, and this is a system. It will be deflected in 4B2. See, guys, the deflection lines. See the deflection lines. Type. Assume you have B3 applied on joint number C, A, B, C, and this joint is not free.
No.
It's not free. Cannot
No
be
horizontal movement.
no horizontal, no vertical, both, because the support, it will be preventing any deflection in this joint. It will tight the joint. Very good. If you have force in B4 for joint ABCD, this joint can be deflected horizontally only, because of the movement in this direction. This
Roller
support
sport.
can move in horizontally only. It means what? Means this joint can horizontally only deflected. What about this joint E? E can be horizontally and vertically as well. Can be horizontally and vertically as well. This is a concept now. We are discussing about the concept now. How to calculate it? I will tell you how to calculate it by we have method, we call it method of a virtual work. Virtual work. What's the method virtual work? Virtual work, we can call it what? You have apply, you have a system, مثلا for example, you have a system trust like that, and you call it this P. You have to calculate all the internal forces due to these external forces, and you apply, for example, you need to calculate the horizontal deflection for joint A. Horizontal deflection for joint A. You are, and this joint applied, there is a force, concentrated load applied on this joint, and asking you what is the deflection for joint A. For this, you are going to do what? The mechanism and steps. Calculate all the internal forces due to this external load, whatever the value of this external load, and go again, apply a unit load, same direction of external load, the unit load 1. Unit load 1. No units, 1. Unit load, put 1. And calculate as well the internal forces due to what? Due to this unit load. Due to this unit load. In the end, you are going to have the summation of the internal forces by what? By adding, I will show you, by adding this formula. You deflection for joint A horizontal equal sigma of BL divided L area E multiply LU. What is this all about? I will tell you again. Memorize the formula, please, and we will go for this formula now. I will give example is much effective, to be effective as to solve one question. It will be more effective. But try to understand this is unit.
What is the formula? PL by AE
Load,
into
I will
4.
write it down. This is unit load and this is external load. I will show to you right now with example. You have question from previous exam. This question from previous exam is the one. The one we have it here. Telling you what? The truss showing below is loaded by concentrated force P at joint A as shown. Vertical load applied on the joint A. And we have hinged support B and hinged support C. The vertical deflection at joint A is, this is the answer, 1, 2, 3, 4. How to solve this question? I will solve it you using what? Using method of virtual work. How to solve it? Let us see. You have hinge B C and you have B. this is
3 meters.
3 meter BC, and this is 4 meter. And that's meaning A, B, C. How many members I have, guys? I have 2 members. I have 2 members. And these two members have a theta between the angle between the 2 members is theta. So I can calculate the AC. I can calculate the AC very simple. Pythagoras, that's meaning this is 5 meter, 5 inch, whatever. Okay, how to get the internal forces? The equation again here, the equation, deflection, vertical deflection for joint A equal what? Sigma B L over that area E multiply LU. This is the formula now. Right. How to use the formula? First, get the internal forces for joint for the members AB and AC. What is the internal forces due to what? Due to this one. I have joint. This is a joint, and I have member, and I have another member. Use method of joint, and let us have, and this is what? This will be, and let us have the forces, internal forces due to this external load. يبقى now this is force F, A, B, and this is F, A, C, okay, and you have a theta here. That means the force F, A, C decomposed to vertical and horizontal. This is a vertical decomposed, and this one is a horizontal decomposed. Okay, very good. Vertical equal F, force FAC sine theta, and FAC cosine theta. Correct, guys, or not? Sine theta and sine theta. What sine theta? Sine theta equal 3 over 5, and the cosine theta equal 4 over 5. Here, come back to our joint. Sigma y is equal 0. Sigma y is equal 0. Yes, sigma y equilibrium. Sigma y is equal 0 means what? Means LF A C. Sine theta is 3 over 5 multiply, equal LB. يبقى then LF AC equal 5 over 3 LB equal 1.67 LB. Correct? يبقى now I get what? I get the forces here. If this forces sigma y, this force downward, it be downward, for sure 100% the force decomposed in vertical direction should be upward. That if this force upward, that's meaning the internal force in this direction. If in this direction, what then? Put your finger here at this joint. This force is press. That's meaning this is compression. Compression means minus. Now this force is 1 minus 1.67 B minus. I get now the internal forces for the internal force in member AC. Right? What about member F, member AB? Sigma X is equal 0. Means what then? Then what? Then F A C cosine theta equal F A B. Yes. If this force in this direction, F A C in this direction, for sure 100% F A B in this direction. If this direction, that's meaning what? This is tension force. Why? Because pulling your finger. Okay, tension force. What is the value of this force? يبقى الاف اي بي اف equal what equal 1 5 over 3 البي multiply 4 over 5 ال5 go مع ال5 that's meaning equal 1.33 البي. Now I got البي الفورس الانترنال فورس for member AB equal plus 1.33B. I get all the internal forces now due to what? Due to the external load B. Function of B. I will erase this part. This part, and please, if anyone already the class is recorded and you can get it at home, whatever. But I will erase this part because I'm going to put the unit load now. I'm going to put the unit load. If I'm going to put the unit load, put the unit load vertically on the same joint. This is a hinged support and hinged support. Put unit load 1. Same direction, guys. Downward, the force being downward, put 1 unit load, 1 unit load. If this one, what does it mean 1? That means the internal forces due to this load in member AB, it will be what? Apply 1 equal tension, it will be tension 1.33 plus tension. And for sure 100% AC force internal in the internal for the member internal force in member AC, it will be equal compression minus 1.67. Now I get all the internal forces due to now to what? To the internal, due to external force اللي هي البي and the unit load, which we call it virtual work. To do what? Do this table. Okay. What is table? You will see what's the sigma you can calculate. Member cross section modulus elasticity البي الفورce internal forces due the external forces, we call it B external forces, whatever the external forces, 10 Newton, 10 kilonewton, 10 kb, whatever, kips, whatever. This is the internal forces due to the external load, and U, the internal forces due to the unit load, U, unit load, and sigma, B, L over area E multiply U. First member is AB. A constant area. E constant E. B equal what? Equal plus 1.33 B. Okay, U 1 plus 1.33. Then the deflection at this member is equal what? Equal 1 plus 1.33 B multiply 1.33 multiply this U and multiply L. Where is L? L here, sorry. L should be here. L equal 3 meter. 4 meter multiply 4 divided area E. Calculate this one. You will find it out is equal 7.07 LB over area E. This is the first part. 1. طيب member AC يبقى member AC الاريا constant الاي modulus constant minus 1.67B and minus 1.67 and 5 meter. Okay, but deflection in this member is equal what? Equal minus 1.67 B multiply 5 multiply minus 1.67 divided area E. This part of the equation is equal 1.7 multiply 1.7 multiply 5 equal 13.94 B over area E. Take the summation plus 707 is equal, it will be equal, the summation is equal 21 B divided area E. This is a summation. Go to our question.